In this video, we are going to see the graphs of lines. We draw the graph using the coordinate system. The Cartesian coordinate has got an x-axis, which is the horizontal line. The vertical line is our y-axis, and the x-axis and y-axis meets at the origin. We have four quadrants: first, second, third, fourth. First quadrant, both x and y are positive. Second quadrant, x is negative, y positive. Third quadrant, both x and y negative. And in the fourth quadrant, x is positive and y is negative. We can plot the points in this Cartesian system. And when we are trying to learn about the linear equations, we have to remember two types of equations. One is a standard form, which is of the form ax plus by plus equal to c, or slope-intercept form, y is equal to mx plus b. The previous equation can also be written in the slope-intercept form as negative a by bx plus c by b. And the horizontal line is when y is just a constant. That is when a is 0 and b not equal to 0. It is a vertical line when x is a constant. So if you're trying to find the x-intercept, substitute y equal to 0. If you're trying to find the y-intercept, substitute x equal to 0. So when you're drawing the graph, the line where it crosses the x-axis will get the x-intercept. Where it crosses the y-axis will get you the y-intercept. We can also draw the graph using a graphing calculator by entering the value of y, and you can easily graph it and then see where it crosses the x-axis or the y-axis. We talk about the slope of a line as the difference between the y-coordinate divided by the x-coordinate. We know that in order to get a line, we need at least 2 points. So let us connect the 2 points x1, y1, x2, y2 to get the line. The slope will be the difference between the y-coordinates, that is y2 minus y1 divided by x2 minus x1. You can even take that as y1 minus y2, but the denominator becomes x1 minus x2, in which case the denominator cannot be 0. So x1 is not equal to x2. That change in y-coordinate will be the rise, and the change in x-coordinate is the run. So we also call the slope as the rise over run. Now in this example, it has a positive slope, the inclination is positive, and you can also get the slope exactly by taking two different points. One is -3, -2, and the other point is 3, 4. So the slope will be the difference between the y-coordinate divided by the x-coordinate. Simplifying that, you get that as 1, and hence it has a positive slope. In this curve, I know that it has a negative slope because it is inclined that way. If you are trying to get 2 points and then take the slope using the formula difference between the y-coordinate divided by the x-coordinate, simplifying, you get that as -2. Hence it is proved that it has a negative slope, and it is -2 in this case. The third case, it is a horizontal line, there is no slope at all, so the slope is 0. You can also prove that by taking two different points, take the slope as the difference between the y-coordinate by the x-coordinate, and it is 0. The last case, I have a vertical line, so we cannot define the slope. It is undefined. By taking two different points and the slope, it looks like the denominator is 0. You cannot divide by 0, so it is undefined. The standard form is ax plus by plus equal to c. The slope-intercept form is y equal to mx plus b. Horizontal line when y is a constant. Vertical line when x is a constant. You can also have the point slope form of a straight line, y minus y1 equal to m times x minus x1. Now let's take these two lines, x plus y equal to 3 and x minus y equal to 1. We can graph these two lines, and the point of intersection of those two, 1, 2, will be the solution to this system. The point where it crosses the meets, when you have a common point, that becomes the solution to the system if you have got two variables. Now in this case, if you have x plus y equal to 3 and 2x plus 2y equal to 6, when you graph it, it looks like both the lines are one and the same. One lies exactly above the other. So it has infinite number of points. All those points common to x plus y equal to 3 and 2x plus 2y equal to 6 are solutions to the system. So it has two coincidence lines, in which case you get infinite number of solutions. Third case, when I have x plus y equal to 3 and x plus y equal to 1, and I graph them, it looks like the two lines x plus y equal to 3 and x plus y equal to 1 are parallel. These two parallel lines do not have anything common, and hence this one has no solution at all. The first one has got one solution, second one infinite number of solution, the third one no solution at all. When you have solutions, they are called consistent. Whether it has one solution or many solutions, they are called consistent system. If they do not have any solution, they are inconsistent system. You can also graph the lines using Geogebra. You need not simplify that as y equals. And also you can make use of those systems in solving problems. Here the company was purchased for $20,000. The scrap value is 2,000 after 10 years. Using straight line depreciation, you are asked to find a linear equation. So when the time is 0, initially it is 20,000. After 10 years, the value is 2,000. So you have got two pairs of points. One is 0, 20,000. The other one is 10, 2,000. So for which you can find the slope, or you can even use the slope intercept form and then find what the equation is. Y equal to mx plus b. Here x is t because we are taking the variable as t, and y is v here, the value. So v of t is minus 1800t plus 20,000. We can also use this in supply and demand. So let us assume that there is a set of values given. In 2002, the supply and demand and the price are given. You can find the linear supply equation. So supply equation of the form P equal to mx plus b, and the demand equation also you can find. And then you can find the point of intersection. So we have pair 340 2.22, 370 2.72. Those are two pairs for supply price. The other one for demand, it will be 270, 2.22, 250, 2.72. So using those, you can find what the slope is and you can solve for P. The same way for the second set of problems. You can find what the slope is and you can find the equation. You can also find the point of equilibrium by drawing the two graphs, the two lines in your graphing calculator. Find the point of intersection. That point will be the equilibrium point. that is when X is 298 million, the price will be $1.52 per vessels. So in this video, we learned about linear equations, applications of linear equations in business programming, and we also used graphing calculator to find what these values are. The main thing what we learned is about the slope, to check whether it has a positive slope, negative slope, and all that. When two lines are there, how to find the point of intersection using graphing calculator. Hope this video was helpful. Thank you for listening and thank you for watching.